sense next year, though. So yesterday, we looked at the first type of fraction. There are 5 really, but 4 that are proper. And that was called the distinct linear. It was distinct because the 2 factors were different. So we worked through that one problem using common denominators, the fact that you can get a common denominator to help actually eliminate the denominator. And then we grouped like pieces together. So what was similar on the left side, what's similar on the right, because we were trying to keep things equivalent by using the like terms. And then at the end of class, we factored number 3. Taking out an x, this is called a repeated linear because it ended up factoring as x plus 1 and x plus 1. You do have to combine them together as a quantity, x plus 1 squared. Because when you're finding a common denominator, it's all of the different factors that make up like your fractions and the largest power of those factors. So the largest power would be that x plus 1. So we have the x plus 1 squared in the denominator. So this is a repeated linear because the x plus 1 squared actually has to be represented twice. The first time as the power of 1, the second time as a power of 2. If it was cubed, then we would have a third one with the power of 3. But they're all considered linear because the factors, the parts in parentheses, are linear. So see if you can try and multiply by the least common denominator, which is always whatever's on the left. Like there should be no guessing. Whatever's on the left side in factored form is what you're multiplying by. And decide what part would go in the numerator so that you can kind of work through this problem. So just think like what's going to go in the numerator, what isn't in the denominator. So Kate, what are you doing here? What do we have left on the left side?
So.
You got your glasses on, all serious back there?
Sorry.
No sorries.
You're saying left or right?
The left.
Wouldn't you just have 5x squared plus 20x
Yeah.
plus 6?
So we would just have 5x squared plus 20x plus 6. You should never have any part of the denominator remaining. Because we're not solving for the x's in the denominator. We're trying to find a, b, and c in the top. So you're multiplying by the whole common denominator, which is the common denominator of the left side. That means we have whatever is in the numerator. And then Kate, along with the a, what goes with the a term?
I didn't FOIL it, I just had ax plus a squared.
So you had ax plus a squared.
I multiplied it by x plus 1 squared, like the whole term.
Okay, so x plus 1 squared. What does x plus 1 squared become? Libby?
X squared plus 2x plus 1.
Right, so this x plus 1 squared really was x plus 1 times x plus 1 prior to us pulling it together. So that means if we FOIL that, we get x squared plus 2x plus 1. That is what we're multiplying the a by. So it was x plus 1 squared, but if you FOIL that, you're now taking a times all of that information, which makes it ax squared, 2ax, the variable is the x, that should go last, and then finally a times 1, so that would be plus a. So that goes along with the a. because it has an x, but it's missing the x plus 1 squared. So whatever isn't in the denominator is the part that's missing from the top. Brandon, the b term on the bottom has an x plus 1, so what does it need?
An x and an x plus 1.
Right, so it needs the x, because that's in the first denominator, and it needs another x plus 1, because it's squared, so there are two of them. It has one of the two. And Brandon, when you multiply bx times x plus 1, you get?
Bx squared plus bx.
Alright, so bx squared, because this is bx times x, and then he said plus bx. Alright, so now we have the last fraction, and it has an x plus 1 squared on the bottom. So, Jenna, what does the c need on the top? Yeah, it just needs an x. It has the other part, the x plus 1 squared, but it doesn't have the x part. So now we have plus cx. So that's using a least common denominator. Really, the denominator's canceling with the part that it has. The part it doesn't have is what's remaining in the problem. And now we need to do a little organization. So just kind of grouping things together that are the same. Chelsea, what's the same up here? What terms can we pull together?
The ax squared and the bx squared.
So the x squared terms, we're going to take the x away because that's the variable that we actually don't want to solve for. So we'll pull it away from a and b. Both of them are positive. So we're just separating the variable from those a and b, c values because those are the coefficients. Brandon, anything else that's the same up here?
Is it 2ax plus the bx plus the c?
Yeah, 2ax, bx, and c. They have an x in common, so again, we're taking an x out because they have that in common. We have a 2a, the b, and the c. And the only thing left that doesn't have an underline underneath it is that little lonely a. Not 4a. It's a great letter, though. Mhm. Questions with that? So this is just more like organizing your information. Just kind of grouping like terms together. Something you would have done in like 6th grade, 5th, 6th, 7th grade, maybe not 5th, maybe 6th or 7th. So after you have everything organized, now our goal is actually to find the A, the B, and the C. And this is where we need to use the equal sign. Equality means something on the left is going to pair with its same term on the right. So Virginia, how can we start pairing things together from the left and the right?
Let's start with 5x squared equals x squared equals b.
Yeah. So the 5x squared has to be equal to the x squared with the a plus b. But because they both contain the x squared, I could take that part out and just say 5 has to be equal to a plus b. Because the 5 is an x squared term, the a plus b are also x squared terms, and our goal is to figure out the a and the b. Virginia, what else?
You do 20 equals 2a plus b plus c.
Yeah. So that would be our x terms. So again, it has an x on the left. It has to be equal to whatever has an x on the right. Like terms are equivalent. That equal sign means pieces of an equation can be equal as well. And then the last part is a 6 with little lovely a. But it works out nice because now we know a is 6. Questions? So now I have a system of equations, 3 variables, 3 equations, but one of the variables we know. Chelsea, if we know a is 6 and we plug a 6 in here, that makes b. And so now we have a still being 6, b being a minus 1, and that leaves what left over for c? The 9. So here we have 12 minus 1, so that makes 11. So 20 would equal 11 plus c, so that means c is equal to 9. So do you take your answer and write it as 6, negative 1, and 9? No, because you're not solving for x, y, and z. We're not finding where the 3 lines intersect, because that isn't where the 3 lines intersect, or the 3 planes intersect, the 3 variables intersect. Those numbers represent the values that go on the top of our fractions. So on the top of the first fraction, which was just an x, is now the 6. On top of the second one, it's a negative 1. And then on top of the third goes our 9. So on Friday, I will be teaching this to Honors Algebra 2. We will start with this problem here. We'll talk about common denominators and pulling those three fractions together to get the original problem. And now we're going backwards and doing it the opposite way. Can you place this minus sign in between the two fractions? You actually can if you want. So if you prefer to have your top numerators all be positive, you can just bump that minus sign in the middle. Because that's another way you'd probably see the problem. So you could have 6 over x minus 1 over x plus 1 plus 9 over x plus 1 squared. Totally up to you. You want to take the negative sign and pull it in front of the fraction. Questions? I know I say this a lot, but I love doing this. I love teaching honors trig and pre-calc. So I just love all of this stuff so much.
I remember last week you were like, I liked teaching art trig and pre-calc, but
Not that I don't like algebra 2, but I just love like all the stuff that we can talk about here after you learn all the algebra 2 stuff.
you seem to be enjoying yourself a little bit more this year than last year.
And, well, last year, I mean, I had to come back after having a year off too, so that was a little rough. Having full year school off and then coming back to work. Tough. That's why you marry somebody with money. You have to say that quietly though, in case Mr. Kane is listening. Having a forever long weekend. That's like 18 months forever long. It's amazing. All right, so number 4, we have a linear and a quadratic. I do love my husband.
I'll be sure to tell you that next year.
So factor the denominator. Your factor should be a linear factor and a quadratic factor. It'd be so much better if you didn't work here. Then I could just like throw them under the bus all the time.
You do anyways.
After 20 years, you're allowed to.
It's not like he's going anytime soon.
I have like the foot of the glass.
You were okay. Mhm. Somewhere, so this at A here should have like x equals 2 and x minus 2. So we need a couple extra terms. Yeah.
And I never saw that. Do you want me to go back and see if I can finish the problems or not?
You can, Brandon, it's fine. Cade, how do you factor the denominator here?
I factor by grouping, so I took like x squared first term,
And you get,
x minus 1,
and then the second one,
2,
and you also get,
x minus 1.
so we should have an x squared plus 2, that's our quadratic factor, and the linear factor is the x minus 1. So it says we should have both, a linear and a quadratic. How many fractions are you going to have? 2, because there's 2 factors. So 2 factors make up 2 different fractions. The first fraction, you can place the x squared plus 2. The second fraction, the x minus 1. Libby, what goes on top of that x squared plus 2?
We do ax plus 1.
Right. None of the homework problems last night should have had an ax plus b because all of the factors on the bottom really were linear. That x squared, when you have an x squared, that's the trickiest thing to think about being linear. But technically it's an x that's repeated. The x part is the factor, the 2 part is a power when you have it by itself. So ax squared plus b, because this is the first quadratic factor we're looking at, and then Libby on top of the x minus 1 is just c. So this is quadratic because it cannot be broken down any further. There's no way to factor that, no way to break it down into separate pieces. It gets an ax plus b because anything smaller than x squared has to be part of the problem on the top. So I can have a number for a and I can have a number for b on the top then. So the denominator on the left is what we take this whole thing and multiply by. And every single time, the denominator on the left is the common denominator, so you'll just be listing the part that remains on the top. Don't factor that. Don't do anything with that, because it could factor, but don't. We don't want to factor the numerator. We need each one of those coefficients to help us with the other side. Even if it's really tempting to factor it, because sometimes it is really tempting to factor it. But if you factor it, then you're throwing off the coefficients, because then that x has a different power to it. So we have to keep it as is. All right, so Eris, there's an x squared plus 2 in this denominator. What does the numerator need?
The x minus 1.
Right, so we have to have an x minus 1 here. That gets foiled with ax plus b. Eris, how does it foil?
ax squared minus ax plus bx minus b.
Nice, good. The second fraction with the c over x minus 1, Kate, what do we need there?
Hold on, isn't it a or bx minus b?
Yep. Yep. She said B. I
And
just
then-
like C apparently. So, Kate, what goes with the second one?
It's plus cx squared plus 2x.
Yeah, so this gets an x squared plus 2. So she said plus cx squared plus 2, and then the c. So it has an x minus 1, it's missing the x plus x squared plus 2. So cx squared plus 2z. Questions? So the more problems you do, kind of get an idea as like the pattern that's working, what do we kind of look for next. You might be able to skip a step or two. But we need to group together the terms that are the same. In this case, an x squared term has to get paired with an x squared term. So that would be a plus b. And then if it has an x with it, we have to pair it together. Well, we have a negative a and a plus b. You never factor out a negative sign or a coefficient. It's just the variable that you're pulling away. Because that negative sign has to stay with the a because that affects the coefficient.
And for the x squared, can it be a plus c?
So don't pull out a 2 if they have a 2 in common. Don't pull out a negative sign if they have a negative in common. That has to stay with those values because it affects the number on the other side of the equation. And then the last pair of terms that are the same are just our numbers without a variable. So a negative b and a 2c. Everything is grouped together, kind of arranged, so now you're pulling from the left coefficient, grouping it with the like term on the right. So whatever's in front of x squared has to equal whatever's in front of x squared on the right. So now we're trying to find those a and c values. Whatever's in front of x must equal whatever's in front of x on the right. And finally, the last number plus c. So those are my 3 equations with 3 variables. Here, 2c. What the heck? I cannot write. How would you solve?
We have to kind of name one variable so we have to
Yeah, so what do you think would be easy to do? Say it again.
the a and the negative
Yeah, the first 2 equations have a positive a and a negative a. So Sabrina said our goal would be to eliminate one of the variables from the problem. So those first two equations, as soon as you match them up, the A can be eliminated pretty quickly. Sabrina, if you combine those together, I'm going to pull it over here, you get A, 8 equals 2C minus, wait, you can write an A in place of B? No. Which ones are you eliminating? I thought you said the
I
first.
have different variables on my on the paper, so I'm trying to figure out what I'm supposed to be doing.
Did you have these flip-flopped?
Yeah.
Okay.
Would it be 2C plus
So if we combine these two together here,
C plus B then
yeah, I'm just gonna write it alphabetical, equals,
is equal to 5?
yeah. So there's two equations, looking at these two, 1 plus 4 is 5, the A's cancel. We have a plus C and a plus B. You can't cancel them out. I just wrote it alphabetical, so the B was first and then the C. So now we have 5 equals B plus C, that's the resulting equation. Libby, what else could we do?
Then you can get the bottom equation to cancel out the b.
Yeah, the bottom equation also has a B and a C in it. So we have 4 negative B plus 2C. And Libby, when you combine those two together, you get,
You can get 9 equals 3c and then c.
and C is equal to 3. So we're still using that like Gaussian elimination concept because we still eliminated the A. So we got rid of the A. By doing that, our two equations that were left have a B and a C in them. The resulting equation and the third equation that was up there. Questions, Kate?
Can you not do elimination and then substitution?
You can do elimination and then substitution if that's what you prefer. Other questions? Virginia?
I did substitution and I got the one.
So did I. I didn't get that.
So you did substitution the whole time? You did no elimination?
No, I eliminated the first two.
And you
I
got this equation?
Yes.
Okay.
And then I solved for c,
Mm-hmm.
and I plugged it into the bottom equation.
So you have C equals 5 minus B?
Yes.
I'll come back and look at it. So the C value we now know is 3. Brandon, that means B is,
I solved for A first.
okay,
I got A to be
B is negative 2. And then A is, it's normal 2, yes, positive 2.
Wait, why am I playing equals?
So if you plug in B to be a negative 2, plug a negative 2 in here,
Wouldn't that mean a equals?
Wait, if 1 equals A plus 3, if 1 equals A
this
plus
is
3.
A, yeah. No.
I know.
I plugged it in here. I should just quit and go home today. Good thing I'm not doing anything after school. Alright, my fault. So A is the plus 3, so 3 taking it gives us a negative 2. And then when you plug in a negative 2 here, that makes B be positive 2. There we go. I'm sorry. So we have negative 2x plus 2 on top of x squared plus 2. And then we have a 3 on top of x minus 1. And if you flip-flop them, so Brandon, did you have them flip-flopped?
No.
No, okay. Sabrina, you had them flip-flopped. And you should still get the same answers even if you have them flip-flopped. You should still get a 3 on top of the x minus 1, a negative 2x plus 2 on top of the x squared plus 2. Even if you flip-flop them, you don't have them in the same order, you should still get the same numbers on top. You don't have to factor out a negative 2 on the top. You could. You don't have to. Because our goal really isn't to simplify, it's to kind of look at the separate parts. Questions, Brandon?
Were you looking at the 3 written over the C, and did you, for the first equation, did you see that as a B?
I think I may have.
Oh,
That's That's what I get for writing over and not rewriting.
It's fine, we all make mistakes. Just students will be teachers.
Yeah, but not today, apparently. All right, so the last one we're going to look at is called a repeated quadratic. So we have the 8x cubed, 13x. It's already in factored form, so you have a step saved here. Virginia, I'll come over and look at it.
I figured it out.
Oh, perfect. Go ahead.
So did I.
Oh, good. Excellent. How many fractions should you have here? 2. If you have one fraction, you haven't broken anything down. Chelsea, how do your denominators look?
X squared plus 2, and then the second one is x squared plus 2 squared.
Right. Nice. And I think like that's the hardest part, is to kind of understand that whatever your power is, you have to have the power that comes before it, and then that power itself. That's why it's called a repeated quadratic. So you have the quadratic there. The first time to the first power, the second time then to the second power. I read it again, it was cubed. Every power has to be represented in the denominator. On the top, because it's quadratic, we get an ax plus b and a cx plus d. So there's 4 different variables that we're going to solve for. And we're looking at x squared plus 2 quantity squared. So what is the fraction in the middle here? What do we multiply that fraction with? X squared plus 2. Yeah. So there's 1 x squared plus 2, but it's supposed to be x squared plus 2 times x squared plus 2. So if you FOIL that together, what do you get? Mm-hmm. We have a cubed in there. That's okay, because there's a cubed on the other side, so that's okay. How about the last fraction? Brandon?
It gives me CX plus D.
Why?
Because the denominator is already the common denominator,
Yeah.
so you don't have to do anything.
So it has the common denominator. It needs nothing extra. It just stays as cx plus d. So grouping the things together, here is an ax cubed. Over here is an 8x cubed. Chelsea, that means a is equal to
8.
because there's no other x cubed term. The next term we have is an x squared with a b. What's the x squared term on the other side? Brandon?
0.
Yeah, there isn't one. So it has to be 0. Going down the line, we have 2ax and cx. So 2a and c have to be equal to the x. Well, the x on the other side is 13. And finally, the 2 parts that are left, 2b and d, those are the numbers. The number on the other side is also 0. So if b is 0 and 2b plus d is equal to 0, Brandon, that means
D is equal to 0.
d is also equal to 0. So we actually don't have the d and the b terms. We just have something with x in both fractions. And we already know a is 8, so 2 times 8 plus c, writing it separately so I'm not confusing myself. Brandon? A negative 3. So my first fraction should have an 8 with the x, and then x squared plus 2. The second fraction has a negative 3 with the x, still x squared plus 2, but that quantity is squared. And again, if you prefer to bump the negative in between and just have 8x over x squared plus 2 minus positive 3x over x squared plus 2 quantity squared, you can find that. Questions? hopefully that